Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host, Samir-Alhindi, and today I will be presenting this 3-day bootcamp where I will teach you how to create video games from scratch. Okay, so first of all, I'd like to tell you about myself. I am a student here with you in the Arab Open University. I'm in my second year. Okay, I am a computer science major. And I've been creating video games for about 2 years now. I've pretty much learned everything, about computer science just from making video games. Okay? So, video games are extremely important to me. They taught me everything, everything we studied. And of course, this boot camp is presented by the computer club here in the Arab Open University. Okay? I'd like to thank my, teammates Sarah and Ahmed for helping me with this, and of course, all the team has helped. Okay. So without further ado, we will start, inshallah, now. Okay. So first of all, I would like to explain our plan. Um, so as you saw in the email, this is basically a 3-day boot camp. Okay. So it's going to be 3 days. In the first day, which is today, it's going to be all theoretical. Okay. So don't worry, you don't have to download anything today. At the very end, I'll tell you how to download the program, but other than that, all you have to do today is just follow along and, try your best to understand. Okay. Day two tomorrow, same time, inshallah, we will start coding. It will be the practical part. We will start coding a 2D game from scratch. No coding experience or anything. Don't worry about it. I'm gonna teach you everything from scratch. I'll treat you like a baby. You pretty much just need to know how to like move your mouse and type things on your keyboard. And inshallah, on the third day, we're gonna continue the 2D game because we're not gonna be able to finish it in 2 hours. It's gonna take, I don't know, 4 hours. So yes, inshallah, this is gonna be a 3-day boot camp. Um, and yeah, okay. And I would like to tell you that, by the way, I can read everything you're typing on the chat. I have an iPad, and so like anything you feel like you don't understand, please do not hesitate to ask. يعني يا شباب أي أحد عنده أي سؤال أو أي استفسار أرجوكم يعني اسألوا على الشات بالعربي بالإنجليزي. أهم شيء نكون فاهمين. تمام. الهدف من هذا المعسكر نطلع فاهمين. Okay. So let's continue. Okay, so right now I'm going to talk about the prerequisites for this course, what you need to know. ايوه الشرح كله حيكون بالانجليزي. So the prerequisites for this course are nothing, okay? Like I said, you don't need to know how to program or like anything, okay? You don't need to know anything about making games. All you need to do is like just know how to use your mouse, on your computer and know how to type things on the keyboard. Okay. Someone's asking if we need a laptop. No, today you will not need a laptop. It's all theoretical today. Okay, اليوم كله نظري. Okay, so by the way, yeah, thanks for reminding me. Um, I'm gonna send you something on chat. I'm gonna send you the slides that I'm explaining right now in both Arabic and English. يعني هذه السلايدات اللي قاعد اشرحها الحين حرسلها بالعربي وبالانجليزي. سويت لكم ترجمة. Just give me a second. I'm just gonna upload the files real quick. Can't believe I almost forgot. Schedule message. Wait a minute. Wait. Um, wait. Not sure how I can like send something here. Wait. Not sure why. Wait. Just give me a minute. False praise. Get more apps. Okay, sorry guys, I'm having a bit of a problem with sending the files. I'll send them after the lecture, don't worry about it. Um, Basically, it's what you're seeing plus an Arabic translation. Okay, so yeah, let's continue. The session will be 2 hours long, by the way. Okay, yeah, I'll send it later, don't worry. Okay, so this part is really cool. So, like, how do companies create video games? Okay, so we always see, these indie companies, these indie studios, I mean, they publish new video games. Like, we saw the new Claire Obscure, Expedition 33, the long-awaited Hollow Knight Silk Song, the original Hollow Knight, Cuphead. Remember Fortnite, the Silent Hill games, like all these awesome video games. Like, how are they created? Well, like, do you think that like the developers go on a computer and do they like just start programming from scratch? Do they just make games like that? Well, no. Basically, in order to create a video game, you first need to download a special program. A program we call a game engine. Okay, so what's a game engine? It's a program that just makes the process of programming games to be very easy. Okay, so if you were gonna make a game from scratch, it's gonna be really difficult and very time consuming, okay? And very frustrating even, you know. So what people do is that they use a game engine, for example, Unity or Unreal or Godot or GameMaker and many more. Now, because we're using a game engine, things become easier since you have things like input, okay? Taking input from the player, with the controller. Like for example, when the player presses the A button, you want your computer to detect that, right? Then you want an action to run. You want the player to jump, for example. Well, if you're going to code that from scratch, it's going to be a bit difficult. It will be much better if you were to use, these game engines, which automate the process of input for you. And not just input, and a lot of other things like showing graphics and stuff. Sounds, the things that all games need, because there's some things that are very fundamental when, it comes to game development. Like I said, taking input, displaying sound. Sorry, I mean, playing sound, displaying sprites, so everything's gonna have that. And that's why we use the game engine. So here I actually have three examples of game engines. The first one I have is probably the most popular game engine as of right now. It's called Unity. Okay, so I'm sure you've heard of Unity. Um, some of the games that have been created in Unity include Hollow Knight and its sequel, Hollow Knight Silk Song, and also Cuphead. And if you remember from 2016, the Pokemon Go game on the mobile. Um, so yeah, it's really popular. And when it comes to difficulty, I would say it's, about medium difficulty to learn. It's not too hard, but not too easy. It uses C# as its language, and yeah, pretty much it's the most popular game engine. Secondly, I want to talk about something called Unreal Engine. I'd say it's the second most popular game engine, but it might become the first. So many games have been made using it. Fortnite, for example, the Silent Hill 2 remake, and just so many games have been made using Unreal. And Unreal uses C++ as its programming language. It's probably the most difficult, but also the most like professional out of the three. Of course, they're all professional, but like it's kind of, it definitely takes a professional to get the hang of it. And last but not least, the focus of this boot camp is the Godot engine. Okay, we're gonna learn all about Godot, from scratch, pretty much. I'll teach you everything you need to know. So yeah, without further ado, let's continue. Okay, so now I'm gonna explain why exactly I chose the Godot engine. Look, I just told you that Unity is the most popular, and then Unreal is the second most, right? And then Godot is currently third, you know? So like, isn't that kind of counterintuitive? Why would I pick Godot? So the first reason for why I chose Godot is because Godot is both free and open source. Okay, wait, let's unwrap this statement. First of all, Godot is completely free. Now, look, something you need to understand is that all three of these game engines are free to start. So with Unreal and Unity and Godot, anyone can download them for free, and then you can make games, and then you can publish them, okay, for free. For example, on the Play Store, on Steam, on the Nintendo eShop, if you have a publisher, uh, on the PlayStation Store, on the Xbox Game Pass. Of course, you can publish it with Godot too, if you have a publisher. But look, after your video game sort of reaches a specific income revenue. So, for example, your game has made $50,000, okay, for example. After that, you're gonna have to pay 20% of your game's revenue to these publishers, So, like, for example, if you're using Unity and your game makes 50,000, after that, you're gonna start paying like 20,000, of your game income to Unity and maybe to the publisher. Of course, these numbers aren't accurate. I'm just giving you an example. Okay, so this is something with Unreal and Unity. Okay, but Godot, on the other hand, is completely free. Okay, there is no fee like whatsoever. What's beautiful is that Godot itself doesn't even have like an owner. There's no Godot company. Um, Basically, with Unity and Unreal, there is an owner, okay? There is like a company that owns the brand, right? But with Godot, there is no owner. It's kind of publicly owned, and basically, there's just the Godot Foundation, okay? They're basically a group of fans, and they just take donations and work on it. But no, Godot is completely free. Secondly, Godot is open source. Now, what that means is that um, with Unity and Unreal, you can't really modify them. Like every program could be open source or closed source. Closed source means the code of the program is, well, it's hidden, we don't have it. We can't really make our own unique version of Unity or Unreal. And also that goes with many other programs. Um, but with Godot, what's awesome is that you can pretty much create your own unique version of Godot, your own like a different version. Like you can change Godot because it's open source, everything is online. You can change it and make your own unique version, which is awesome. And this goes hand in hand with Godot being free. So since the engine is free, it's also open source. And since it's open source, it'll always be free. Exactly, yes. You can fork it, customizable, like Linux. Yeah, amazing. Yeah, exactly. It's like Linux. That's really good. So that's the first reason. And the second reason, I think is something really important that a lot of people forget is that Godot is just, very optimized. Basically, it can literally run on a potato, okay? So with Unity and Unreal Engine, I'd say Unity takes like a medium end like computer, so it doesn't have to be high end, but at the same time, you probably can't make games with Unity, with a lower end computer. Maybe you could, I'm not sure, but it's probably like a bit computer intensive. And Unreal Engine, you just need you really need a high-end computer, okay? If you have a low-end computer, you want to make games using Unreal, it's just not possible, as far as I'm aware. But when it comes to Godot, what's amazing about Godot is that it literally it can run on your phone, okay? There is on the Play Store. You can download Godot and program games. Also on the Apple Store and on your computer. My computer that I'm working on right now is, I'm gonna be honest, is it's very weak, but it can run games and make games fine. And my previous computer did not even have a GPU. Can you believe that? But it ran Godot just fine. So it's really amazing. This makes it very accessible, okay? anyone can program games, literally anyone. Yes, it's amazing for low-end PCs. You need the nuclear reactor for Unreal. Yeah, I've heard of that. It's super lightweight and portable too. It's really amazing. So these are the first two reasons. Now, the third reason, which also is extremely important, is that pretty much out of every game engine, Godot is the easiest, okay? So there is li so out of the three engines, Unity, Unreal, and Godot, the most difficult would be Unreal because it's more professional and it uses C++. But then would be Unity, which I'd say is like medium difficulty with C sharp. But then lastly, Godot is the most easy, okay? The sort of it's very intuitive and it simplifies a ton of stuff. It's kind of made, with this whole, purpose of getting things done, getting your games done, you know, kind of no bull crap, just, no boilerplate code, just get things done. Okay. Uh, so yeah, it's really easy. And lastly, of course, there's other reasons, but the last reason for me personally is that Godot has like such a beautiful and kind and honestly accepting community. So, of course, all three game engines have good communities, but like Godot, especially since it's kind of targets beginners, there's a ton of beginners, and it's just these beginners, they can ask anything on the official Godot forums. Okay, there's an official forum, of course, where you can make a post every time, you encounter a problem with your game. Because of course, while you're coding a game, you're gonna have problems, right? You're gonna have bugs. So you can ask people, and when you ask them on the forums, people are gonna be friendly generally. Even if you like ask like a really like, I guess, stupid question, even though I don't believe in stupid questions, but like it's really, really beautiful. Like everyone is just so accepting. People will be patient with you, okay? They will teach you. They will sort of hold your hand until you figure out your problem, and they'll never get mad at you. Kind of computer science is a bit notorious for not being, beginner friendly, but Godot is just the sole exception, honestly. Um, Everyone is like so accepting and so patient. It's just really beautiful. Okay, so let's continue. Okay, so in our next section here, I kind of just want to point out a couple of games. Okay, just four of them. There's many, many more games made in Godot, but these are just a couple of them. Okay, so the first game that I want to talk about is a very popular roguelike game. It's called Potato. Yes, it was created using Godot. I think it's a really amazing game. Honestly, it's really, really awesome. I'd highly recommend it. I think it only costs like $1 or like five. It's really, really cheap, and honestly, you can get so much enjoyment out of it. I'd highly recommend it. Okay, it was made in Godot. Uh, the second game I want to talk about it's called Buckshot Roulette. Basically, it's a horror game. Okay, and it's 3D. By the way, I didn't mention that Godot is, of course, you can make 2D games and also 3D. It's professional after all. Like I was saying, Buckshot Roulette is a 3D game, but what's cool is that it looks like a PS1 game, or like a retro game, the Sega Saturn, Nintendo 64 type of thing. And that's really cool. You can achieve that with shaders. So the game itself it's a masterpiece, basically, in atmosphere and like gameplay and concept and art. And even Markiplier himself played it. And overall, it's just a very popular game. It's really awesome. Okay, it's literally $1, by the way, on Steam. Okay, so oh no, it looks like you guys are looking for redevelop. Redevelop is not Godot. It's something else. Um, okay, redevelop is not Godot. It's something else entirely. I'm sorry, it looks like Godot isn't on the App Store. I must have gotten confused because there is actually a port for iOS, but I don't think it's like licensed. So that's why you won't find it on the Play Store. So anyway, I'd like recommend using a PC, of course. It is on iOS. There is a port, but it's not on the App Store. Thirdly, you're gonna be shocked, but Sonic Colors Ultimate, the buggy remake of Sonic Colors that released a couple of years back, was indeed created using the Godot engine. So what happened was kind of dirty. So basically, when Sega, the publishers of Sonic, when they published Sonic Colors, they did not mention Godot anywhere in like the credits. Like nowhere. Like Godot was not mentioned, despite the fact that it's actually, like we said before, it's free and open source. So they used it for free and they did not even credit it. Like, I mean, that's pretty dirty if you ask me. They could have, at the very least, just added credit. So then, you guys know Sonic fans, they're very talented people. They really love data mining their games. So they data mined the remake of Sonic Colors Ultimate, and guess what they found? They found that it uses the Godot engine. So they posted about it on Twitter, and Sega themselves kind of apologized. And after that, they did update Sonic Colors Ultimate to credit Godot. Okay, so I know Sonic Colors Ultimate has a lot of bugs. It's a buggy game, but I assure you, these has nothing to do with like Godot. Uh, it just has to do with the fact that Sega themselves rushed the game. Yeah, exactly, Sega. Yeah, I don't want you to think that like, oh, the game is bad because the engine is buggy. No, the engine is like perfect. It's just that they really rushed the development. It's okay. Yeah, it's technically legal, but like, I don't know why they wouldn't do it. So okay, and lastly, this game is really fascinating. So the game Dog Walk, you're not gonna believe who made it. The people who developed this game are none other than Blender Studios. Yes, Blender, the one and only. Now, I'm sure if you've dabbled in any 3D animation or any 3D modeling, any 3D game development, you are guaranteed to be familiar with Blender. Okay, Blender is a free and open source software for 3D modeling and also 3D animations. Okay, so to think that the people who made Blender also decided to make a game using Godot is just awesome. And what's the kind of cherry on top is that Dog Walk is a free and open source game. It's completely free on Steam, and the source code for the game is online. So, okay, uh, let's summarize here. We have a free and open source studio, the people who made Blender. They use the free and open source game engine, that being Godot, to create a free and open source video game. Okay, isn't that just crazy? Like, everything about this game is just like public. Okay, it is a project purely created for education. It's amazing. It's just so beautiful to me, honestly. Like the way it's just owned by everyone. Was Little Nightmares created using Godot? I don't think. No, no, it's not created using Godot. Who told you that? No, no, it's not. No. So, like I said, these are just four games created with Godot. Okay, we're gonna check out more games if we have time, but just know that if you go on the Godot website, you can see all the games created using Godot, and you might find out that your favorite game ever has been created using Godot. Okay? Okay, so that was just a cute little introduction. And now we're finally gonna learn about sort of the skeleton of the engine, okay, how it works. Okay? So first of all, how are Godot games made? So right here, I have a screenshot of a simple game made in Godot. Okay. No, Celeste is not made in Godot. Celeste is made using Game Maker. Okay. Here we have a screenshot of a game made in Godot. So in this game, you can see we have a main character, and he has a gun. Okay. He also has a health bar, and the character is shooting bullets using the gun at the slime enemies. We can also see trees and a white background. So It's a simple game. So what I want you to know, what I want you to put in your head, the main idea is that in Godot, every element of your game is a scene. Okay? So basically, your game is a scene. Okay? It's one big scene that contains other smaller scenes. And those little scenes, they also contain scenes in themselves. Okay? It's a tree of scenes. So, for example, the game is a scene, right? And this scene contains the scene of the player and also the scenes of the enemies. The scene of the player contains two other scenes in it, the gun scene and also the health bar scene. The gun scene spawns the bullet scene, okay? So what we have here is that everything is a scene. The enemies themselves are also scenes, of course, but because we have so many, we just use one scene. We create one enemy scene, of course, and then we duplicate it. Okay, so we have many copies of scenes. Same with the bullet. We have one original bullet, and then we create copies of these bullets. Now, I know this is yeah, same with the trees, amazing. Now, I know this is all very abstract right now. It's kind of mysterious, but just right now, I want you to put um, the concept of everything is a scene, okay? In your head, it's extremely important, okay? Everything you see is a scene, okay? Like I said, everything is a scene. The player, it's basically the basic building block of your game. You know, they're kind of like Legos. You're gonna have your scenes you create, and you're gonna compose them and make your game. And your game itself, like I said, is one sort of main scene that contains other scenes. Exactly. So like objects, they're all scenes. A lot of scenes in one scene. Yeah, exactly. Yeah. Okay, so yeah, everything is a scene. So here I have a very simple demonstration of sort of the player scene, okay? We have the main character scene or player scene, and inside of it, we have the gun scene, okay? And the gun scene itself, it creates copies of the original bullet scene, okay? As you can see, there's just one, main scene, but we create copies of it. So this is really important. You have to sort of remember this. Remember the concept. Everything is a scene, okay? And scenes can contain other scenes. They will contain other scenes for sure, okay? Like I said, we can create as many copies as we want. It wouldn't make sense to create 100 slime scenes, right? No, we just create one of them, we save it, then we create copies or duplicates or instances, you know? Okay, so right now I just told you about how everything is a scene, okay? But like, so where do these scenes come from? Like, are they gonna be pre-made for me? Am I gonna open the engine and I'm gonna see like a player scene already made for me and like an enemy scene? Well, no. Frame by frame, no, not frame by frame. We're gonna explain this. Basically, scenes are not pre-made for you. You have to create scenes. But how do you create them? What are they made of? They are made of something called nodes. Okay? So the scenes are made up of collections of nodes. Now, nodes are like the smallest building block of your game in Godot, okay? The nodes themselves are built in, okay? So the scenes are not built in. You have to make your own scenes, but with nodes, no. The nodes are ready for you, okay? They are available in the engine and you simply combine them exactly like Lego pieces, okay? We have these predefined Lego pieces and we build them together, literally like Legos, and we compose a scene. Does this apply to other engines? In other engines, yes, the same concepts do apply, but yes, everything is a scene in other like what's it called? Other engines, but we don't use nodes, we use components. Sometimes we use actors. it's all the same thing. You just same concept, but slight differences and sort of different names. The implementation is like is a bit different, you know? Scratch. I'm not familiar with like I'm not that familiar with Scratch. Nodes are attributes. Okay, good thinking. Yes, technically, nodes are actually attributes of scenes. That's really good thinking. Yes, because if the scenes are made up of nodes, then yeah, the nodes themselves are like, I mean, technically attributes. Yes, amazing thinking. Yes, the meeting is recorded, and we're gonna see that there's a lot of like really cool types of nodes. Does it look like OU build? I don't know. Okay, so in Godot, there is a ton of nodes, okay? I'm gonna surprise you a bit. There is 219 types of nodes, okay? But don't panic, okay? Don't run away. You will not use even like 25% of them. You will not use most of them. Here we're gonna use called the 80-20 rule. You know, it applies to pretty much all programs. Um, 80% of the time, you will only use 20% of the features of the program. Okay? You know, think about Photoshop, for example. There's like hundreds of features, but when you go into Photoshop, do you like even know half the features? No, you don't. There's kind of a couple of them you use, okay, right? 20% of them you know how to use. And that's it. That's enough. You know, the other uses are niche, okay? They're specific for very specific purposes. And just like that with Godot, we pretty much I'm gonna estimate we're gonna need, in order to make, you know, simple games, you maybe only need 10 types of nodes, okay? 10. That's it, okay? Because like we're gonna see, some nodes are very essential, okay? You cannot have games without this node. But other nodes are sort of oddly specific, like they're very specific to very specific circumstances, you know? So we're gonna see them. So here I give you an example of six nodes, okay? So in my opinion, these are the six most sort of essential nodes, okay? I think these will be in most games, okay? Of course, there's a couple of others that are essential, but I decided to choose these ones. Like, I think they're, you know, pretty important and easy. So the first one I'm going to explain on the top is called an animated sprite 2D. And first of all, notice the fact that it ends with 2D, you know, because fun fact, Godot can make 3D games, right? So there actually is an animated sprite 3D that's used for 3D games, okay? But here we're gonna focus on the 2D one. You know, so basically the animated sprite 2D, um, it basically stores and plays simple animations, you know? So, for example, if you're making a simple 2D game and your main character, you know, when your main character walks, it's gonna appear like they're walking, right? It's an animation, you know. It's gonna have frames. There's gonna be like 12 frames per second, you know, exactly 2 frames, kind of like that sort of stuff. It gives you the illusion of movement. So, basically, we're gonna draw like or download our sprites online. And then we're going to use the animated sprite 2D in order to store the animations and also play them and control the frame rate, control the speed, you know, that sort of stuff. Um, you know, so for example, you're going to see how when we want a scene that has animations, we add this node as a child, you know, we're going to see that. Don't worry about it. But for now, it's a simple node, okay? Secondly, and a very important note that I think will be very intuitive for most of you, the collision shape 2D is just used for detecting collisions. Okay, basically a hitbox or hurt box. So of course, you know, if you play fighting games or any game with combat or movement, you know, Souls likes, Street Fighters, Mortal Kombat, anything with fighting, you're gonna be familiar with the concept of hitboxes. In Godot, how do we create hitboxes? We use the collision shape 2D. So it's very intuitive, okay? I think it's very easy. Okay, so next, we have another very simple node, the color rect. It's short for color rectangle. Basically, it's just a rectangle um, that basically just has a simple color. It's really helpful for like when you're making a prototype, you just want like a simple box, an ugly white box or like a cute little background. Um, yeah, Widowmaker hitbox is snatched. Yeah, exactly. What are hitboxes? Amazing. We're gonna explain them in detail, but basically, when you in a video game, when you want two things to kind of touch each other, you have to specify like the size of like it's hard to explain without visualizing. Don't worry, we're gonna get to it. We're gonna implement it. Collisions simulate physical interactions. Exactly. Amazing. Don't worry, we're gonna implement all this tomorrow in the practical session. I know right now some things are gonna appear pretty abstract and I guess mysterious. But once we start implementing, it's gonna become second nature, okay? When I started, it was kind of overwhelming. It was very overwhelming, I'm not gonna lie. But you're gonna see that it's kind of the same concepts. You're gonna use them in every game, and eventually you're just gonna like understand them intuitively. It's gonna become second nature. Okay, so before we continue with the timer, I would like to point out that, as you can see, each of these nodes does exactly one or two things, right? They each have a very specific purpose. And that's kind of what we talked about when we said that the nodes uh, are like Lego pieces, right? Each Lego piece on its own can only do one thing. But when we combine them and we make sort of scenes, okay? When we combine nodes into scenes, now all of these things together, they make something very complex and amazing. We're gonna see it. We're gonna see how we have complex scenes made up of like simple nodes, simple Lego pieces. And it's so awesome, like also beautiful. We're gonna see it now. And now we're gonna sort of continue the nodes. We have the timer node. This node is essential, okay? It is very important. Basically, with the timer node, you yourself choose a time, for example, 5 seconds, okay? And then you start the timer. And when the timer reaches zero, okay, it's gonna start at five, then it's like gonna count down to zero. It's basically gonna execute, some sort of event when the timer reaches zero, or execute some sort of function. So for example, let's say that I'm making a game where I spawn enemies every 5 seconds. I would put a timer and I would put it so that every 5 seconds it's going to execute some action, right? And what it's going to do is every time the 5 seconds pass, it's going to spawn an enemy. So it's really simple, it's really intuitive, and it's very important. Quick time events, yeah, yeah, that's good thinking. Yeah, we could actually use them for these annoying QTEs that they're in every game, kind of like a counter in a loop. Um, I wouldn't say it's like a counter. Yeah, kind of. Yeah, if you wanted to count how many times you're gonna do something, then yeah, it's like that. You can make a timer using delta. We're gonna learn all about delta time, by the way, tomorrow. It's very important. It's good you have that in your mind right now, delta. The fifth node is, again, another intuitive node, the label node. Basically, all you do is just like write the text you want displayed, and that's it. For example, the name of the character, the current objective, the menus, uh, anything, any writing you see in your game, you're gonna use a label, okay? It's so simple. Yeah, yeah. And lastly, we have a very important node called the audio stream player. Now, I know the name is kind of weird, but basically it just plays a file, an audio file, that's it. So for example, the music, if you want background music in your game, you use an audio stream player node and you put the MP3 file or .ogg and that's it. For example, when the character jumps, you want a sound effect to play, right? So you just make a node you title it jump sound effect, and you give it the sound effects file, and you program it so that every time the player jumps, the sound plays. Of course, every sound effect will be implemented like that. So yeah, I think as you can see, these nodes on their own are very simple, but together they're very powerful, okay? So now we're gonna move on to the next slide. Okay, so I've kind of been yapping about how the scenes are made up of nodes, right? But I didn't really explain how exactly. I mean, are we just gonna like take the nodes and like put them together, like tie them up with like a rope, and we just call that a scene? Well, no. So basically, in Godot, the way that we sort of organize the nodes is in something called a tree. Okay, we organize them in a tree of nodes, a node tree. So basically, here you can see in this image, I have a parent node, okay? Or if you were to think of it as a tree, it's the root, okay? The root of the tree. And this parent or root has two children, okay? These children are nodes, okay? So you can also think of them as branches. So this root node has two branches, the first branch and the second branch. And it just so happens that the second branch or the second child also has a child or a branch. Okay, so here I called it grandchild. So as you can see, each node can have children, okay? And it can have, an arbitrary number of children, okay? From 0 to infinity. And each of these children can also have a random number of children from 0 to infinity. It's like art layers. I wouldn't say it's like art layers because I know what you're talking about, but no, it's a different concept. No, I wouldn't say it's like art layers. Um, so this is basically how we sort the nodes. We're gonna have our main node, our parent, our root, and it's gonna have its children that it kind of owns. Okay, it kind of owns its own children, and each child owns, its own child. So we're gonna see all about that. So now we're gonna like take a step back and kind of revise everything we've done so far. Sorry, what's the difference between the child and the grandchild? Look, I named it grandchild because, just to clarify, um, I mean, it's kind of the grandchild of the parent, if you were to think of the parent as like, a parent, literally, then it has two children, and one of these children has a child, therefore it's a grandfather or grandchild. Look, usually I'm gonna be honest, we will not use the concept of grandchildren or grandparents. Uh, we use the concept of children, okay? But we're not gonna use grand. Here, I just did it for clarity, but yeah, you're not really gonna hear about that. Included within. Look, a good question. Are the nodes included within their parents? This is an interesting question. I would say no, they're not. They kind of follow them, okay? They're owned by their parents, but they're not exactly part of them. If that makes sense, we're gonna learn all about it. Don't worry. They're not inherited. You're thinking about inheritance. Okay, no, this is not inheritance. No, some people get confused here. They think that the parents. No, no. Yes, it's true. Inheritance is a tree. Uses a tree structure, but no, the node the tree is not inheritance. Okay, it is something completely different. No, it's not inheritance. Yeah, when you move the parent, it moves the child. So when the player moves, the sprite moves, right? The hitbox moves. It's just composition. Exactly. It's composition. It's not inheritance. Okay. What a happy family. Exactly. Exactly. They're a family. Okay. Not sort of like, you know, that's really good. That's a good way to think about it. Um, Okay. So, like I said, now we're gonna like take a step back and kind of revise everything so far. So a scene is basically a tree of nodes, okay? Also, you can think of it as if they're interchangeable, by the way, okay? This is something really important. A scene can also be thought of as a tree of nodes, they're the same thing. But like you can also imagine that a scene could also be a tree that contains one node. But right now, I just need you to know that a scene, here we have the player scene, it's basically made up of this tree. Here we have the main sort of root, okay? The root or the parent node. We call it player, okay? It's the same name as the scene. As a child, look, it's child, it has a hitbox. So the player has a hitbox. Scene equal nodes, amazing, exactly. And a player has a sprite, right? It has animations, so we give it an animated sprite node. Also, when it gets hit, it plays a damage sound. So we give it an audio stream player node. So as you can see, here we took these four simple nodes and we combined them together to create this scene, okay? And each node has a specific purpose or functionality. Okay, and of course they are sorted in a tree. We have the main parent, the root of the tree, and then we have all the children. Okay? So now we can see that the game itself is, like I said, a collection of scenes, but can also be thought of as a scene itself, okay? And each of these scenes is in itself a collection of nodes. And also, a scene itself can just be thought of as a node. So I want you to imagine that the game is like the human body, okay? The human body contains different sort of systems, right? We have the nervous system, the respiratory system, the urinary system, the skeletal system. The systems are like the scenes. They're kind of big, okay? You know, and each of these scenes or each of these systems is itself made up of sort of body parts, right? For example, the skeletal system contains your skull, your rib cage, all your other bones. So it's also made up of other smaller parts, right? And these parts can be thought of as the nodes. All different jobs, but make us us kind. Exactly. Okay, so at the most fundamental level, the smallest sort of atomic like building block is the node. Okay. Also, you could think of them as like atoms and molecules. For example, the nodes are like atoms, like hydrogen, helium, you know, and you can think of the scenes as molecules. Um, for example, H2O, water, sodium chloride, kind of how the atoms combine to form molecules, the nodes combine to create scenes, okay? That's another way to think about it. Yeah, yeah, exactly. Cells. You can think of them as cells even. Yeah, amazing. Whatever works for you. It's a tree where the parents is the game and the child are the scenes. You can think of it amazing, amazing thought pattern. Yes, you can think of it as a tree where it's kind of like the main thing is the game. The different components of a game are the scenes, and the different component of each of these scenes is a node. Amazing. Ingredients to make pizza, also amazing. Yes. Uh, a computer is also made up of different components, like a keyboard. Yeah, exactly. Amazing. Amazing. So I think this is really good that you guys are getting the hang of this like pattern. Amazing way of thinking, by the way. Okay, so now we kind of understood the sort of skeleton of the games. Now we're gonna get to the part that's kind of daunting and scary for a lot of you. Programming. Honestly, yes, it was scary for me too, but we're gonna see how it's actually not hard at all. It's actually an easy skill. I consider it to be easy if you think about it correctly. So the thing about game development is that you cannot make games without programming, okay? So I'm sorry, guys, if you're thinking about like making games without writing code. It's just not possible. There's no way around it. And that's actually okay because coding is awesome. Okay, it's fun. So uh, the screenshot here is not Python. This is GD script, by the way. GD script is the language of Godot. We're going to learn about it. It looks like Python, but it's not really Python. Anyway, let's just get into the section. Okay, so like I promised you that in this bootcamp, you do not need to know how to program, okay? And I still stand by that claim. You do not need to know how to program, okay? I will teach you everything from scratch, okay? I will treat you like a child. So do not worry. I will teach you everything. First of all, in order to program, we first need to define programming, okay? So what is programming? And at its most basic form, programming is writing instructions for the computer. Okay, so we're gonna write instructions like, taking input and logic. We're gonna see it, but that's kind of it. You're writing like instructions to the computer, and the computer just runs them. Okay, it's essential for making games. Yes, okay. About the languages, don't worry, we're gonna get to them yet. Okay, so now here's the thing. Programming is a process of writing instructions to the computer, okay? But there's a lot of different ways to write instructions. We call these ways programming languages, okay? Now they're all fundamentally like similar. They just kind of differ in the details. But basically, you're gonna have to choose one of them to program games. So the Godot game engine itself actually supports three programming languages, okay? Which is kind of unusual. Usually you get like one or like two max. Three is a bit of a pleasant surprise. So the first language that Godot supports officially is C++. I'm sure you've heard of it. Basically, C++ is a difficult language, okay? I would not recommend it as your first language, but because it's difficult, it's also very powerful. The games that are created in C++ run very fast, okay? C++ is a very powerful language because it's very close to the hardware. Exactly, it's low level. It's not low level, it's lower level, okay? Because if we were to talk about low level, we'd be getting to assembly. Technically, it is high level, but it's lower level compared to like other languages nowadays. I mean, if you were to for example, compare Python and like C++, C++ is definitely like low level compared to that. And Unreal Engine, okay, the one I showed you at the start, actually uses C++. So yeah, if you know C++, you can use it in Godot. But like I said, it's really difficult. So we're not going to use it. Our second option is something easier, a language called C sharp. So C sharp is, I'd say, when it comes to difficulty, a medium language. So if you were to imagine that C++ is hard, then this C sharp is like medium hard. Medium. You don't have to worry about like the memory management stuff, but like it's still kind of have to worry about like types. So there is a bit of overhead. But yeah, Godot supports it. And what's awesome is that if you're coming from Unity, because Unity's main language is C sharp, and it may or may not be the only reason anyone uses C sharp nowadays. Of course, that's not true. I'm joking. People use C sharp for other things, but right now, I think the most popular thing for C sharp is Unity. Um, you can use it in Godot. So if you're migrating from Unity to C sharp, you're moving from Unity to learn. I'm sorry, I mean, you're moving from Unity to Godot. You can use C sharp. And lastly, but of course not least, um, we have a special programming language called GD script. It stands for Godot script. So basically, GDScript is a special language designed just for Godot. So you cannot use it anywhere, only inside Godot. Okay, that seems like a limitation, but because it was made specifically for Godot, it is very easy to learn with Godot, okay, because it's optimized for it. It runs amazing, okay? With Godot, it will run amazingly because it's specifically optimized, created for Godot, okay? It's also such an easy and like amazing like language, you know, and it looks like Python, okay? We're gonna see about that, but we're gonna use GDScript. That's the logo, by the way. So now, why did I choose GDScript, right? Didn't I just say that it can only be used in Godot? Doesn't that seem like backwards? Like, why the heck would I use a language that only works in one program? Like, that sounds pretty stupid, honestly. If you told me that, I think that's pretty stupid. But you have to understand that it's specifically made for Godot, meaning that when you develop games using GDScript, you're kind of working directly with the engine. So it's clear, it's easy, you code fast, you know? It's optimized. The games will run amazingly, okay? It is not the fastest language in the world, I'll admit, but it is like, it's amazing, you know? And it looks like Python, okay? If you guys see, some of you thought this was Python. This is not Python, this is GDScript. It looks like Python, and it's honestly very similar to Python. Almost identical in some places. You see the for loop here, that's just a Python for loop. The if statement, that's just a Python if statement. So it uses indentations, you know? So where like you have to care about the kind of tabs, the spaces. Um, Also, there's no semicolons, which is just beautiful. It's like Python. Uh, so yeah, basically Python, literally. Except when you define a variable, you use the var keyword, okay? There's like other small things, but it's so when you define a function in Python, we use define, but like in GDScript, we just use func. Okay, so like it's such a small difference, but like basically same thing. So it's literally it was my first language. Okay, my first language was GDScript, and I'm gonna tell you something about myself. I just love programming languages so much. I have a passion for designing them, okay? Outside of game development, I personally like to create new languages, and I've created two new languages, okay? And because I love languages so much, I myself have learned Python and Java, okay, and C and Haskell, and I know Kotlin, okay, and I know Dart and GDScript, okay? So I know about 8 programming languages. And if you include the two I made, that's 9. I love languages, okay? And out of all these languages, GDScript might be the best language, okay? I am not exaggerating, okay? I love programming languages more than anything. I love sort of, how to explain it? Like, it's kind of complaining about them, kind of like, you know, I have such a passion for them. And like, out of all of them, GDScript is kind of the golden standard for me. It's like, it's so modern and slick and like elegant. It's easier than Java, yes. It's like it's so beautiful. Like as a language, I just adore it. And you're gonna love it, okay? It's my first language and it's made me fall in love with programming so much. And yeah, it's easier. It's as easy as Python, okay? Like really easy. So here I demonstrate some very simple GDScript code, okay? So here we have the 9th line. Here we define a function using the func keyword, okay? The name of this function is process. So what does process mean? It means that the code inside this function is gonna run 60 times per second, okay? It's gonna run every frame. So ideally, your game would have a constant frame rate, right? It's gonna run at 60 frames per second. So every frame, this function is going to be automatically called by the engine. And basically, it's going to do all this code, right? Every frame. So when you want something to always be running, like every moment, you put it here, right? For example, taking input. So here I have something called an if statement. Now, what is an if statement? It's basically like a check, okay? We're checking a specific condition to see if it's true. And if it is true, we sort of execute a group of code, right? So let's try to read it together. If this condition is true, and then semicolon, the end of the condition, then run this code. So the condition is input dot is action just pressed, move right. So basically what this is saying, if the player presses the key that is called move right, then we're going to execute this code that presumably, based on the name, should move the player to the right. Okay? So let's revise. If, that's the if keyword. Input. What is input? It's basically like an object that contains a lot of like useful functions and variables. Okay, that's an object. And don't worry, I'm going to explain this all in the practical. I'm just kind of going over it real quick. Okay, and one of these things inside this object is a function called isActionPressed. Okay, and I'm basically gonna call this function or apply it. If you remember the functions we studied in mathematics, you know, f of x, g of x, h of x, they're um, they're the same concepts, you know. They're also functions. These functions take input and return output. So the input I'm giving to this function is the name of the key. Notice the name of the key is surrounded by these double quotations because it's a name, literally. It's a text. So this function, which is called isActionPressed, takes the name of a key and it checks if it is pressed. If it is pressed on your keyboard or your controller or whatever, it will return either true or false. If it is pressed, it will return true. If it's not, it will return false. So if the player is indeed, if the player is actually pressing the key on the keyboard that is called move right, then I want you to execute this code. Now, what is this code? Position dot x plus equal 10. Okay, let's unpack this real quick because it's kind of complex. Position is الإحداثيات. Okay, بالعربي position معناها الإحداثيات. Position is basically where the player is on the XY sort of plane. Another concept from mathematics is the XY plane. You know how when we go to the right, we increase X, right? And when we go to the left, we go to negative X. Remember? We decrease X. When we go up, we increase Y, and when we go down, we go to the negative Y. It's exactly like this in programming. So basically, if the player presses the right button, we're going to go to the position of the player. We're going to go specifically to the X coordinates. We're going to increment them by 10. Okay, how do I know it's incrementing? When you see something like plus equals, it means increment the value. Okay, if you write plus, it will not change anything. Okay, you need to do plus equals. And we're incrementing it by 10, right? But what exactly is 10? I mean, is it 10 pixels or like 10 meters, 10 centimeters? It's 10 pixels, okay? So if this will run at, ideally it would run 60 times per second, then technically here, I'm moving the player at a rate of like, of 10, not 10, like 10 multiplied by 60 every second, right? That's 600. So yeah, here we have the players moving at like 600 pixels per second, you know? Can we adjust the speed too? Of course you can adjust the speed. We'll do that. Axes, amazing. Yes, the XY axes. Does Blender use a programming language? No, I don't use Blender, but as far as I'm aware, it's kind of graph-based. but I'm sure you can write code with an extension. I thought it's Python. Yeah, it's so similar to Python. Yeah, don't worry. I'm gonna like send the recording on Outlook. What's in the parameters of the function delta? Amazing. It's good that you're paying attention. Delta is something really awesome that we're gonna talk about later. But to give you a summary, I said that ideally the game should be running at 60 frames per second, right? But of course, that's never going to be the case. Never. Okay, it's never going to run like that. It's always going to be kind of stuttering. It's going to be hovering around like 55, 65. And basically, if you're on an older PC, okay, for example, my PC is very old and low end, so it might run the game at 30 frames per second. And that's bad because, like I said, I want the player to move at 600 pixels per second. So if this is not being called 60 times, my player is going to be slow. The game will run slow on older devices. And the opposite is true. If I'm running this game on a very powerful PC, a high-end PC, what if it runs on like 120 frames? This is going to get called way more than it should. My character is going to blaze over the screen, okay? That is not allowed. Therefore, we use delta. Godot gives us this parameter, delta, and depending on your hardware, delta will either be a very small number or a very big number, okay? So if you're, for example, if your PC is very weak, it's gonna the PC will run the game at 30 frames per second. Delta will be equal to 2. It will be a big number. And we have to multiply the position, we have to multiply 10 by delta. Why? So 10 can become 20, and the character can move at the correct rate, which is 600 pixels per second. Okay? Yes, exactly. Delta works exactly based on your computer's strength, okay? Strong computer and weak computers have different deltas. So for example, now we're going to talk about a strong computer. I want the game to run, like I said, 60 frames per second. But what if the computer is really strong and really fast? It's going to run it at like 120 frames. Then delta will be equal to 0.5. Of course, I don't have to calculate delta. Delta is calculated automatically by the engine. So I'm going to multiply 10 by half, okay? So it will be 5. And because this is getting called 120 times per second, it will move at the correct speed, okay? So as you can see, delta is very important, okay? It's extremely important to understand it because here I should multiply by delta. This code is wrong, by the way, but I wanted to keep it simple, but then you asked about delta, so I kind of I kind of got excited. Does delta force the game to run at a certain speed? Exactly, yes. Yes, exactly. Um, Delta is like a standard. Yes, it standardizes the speed. It improves the FPS, I guess. Yes, it makes sure the game runs stable, okay? The game will be stable. It will run on the same speed across all hardware, okay? Your character will be running at the same speed, independent of the strength of your computer. Movement, yes, movement. سؤال لو حركت 10 بكسلات اليسار مثلا هل بيفرق لو كان حجم المجسم كبير؟ يعني بتتغير قيمة البكسل؟ لا ما يفرق. اوكي هو حسب حجم الشاشة يعني. Okay, he's asking about the screen size. Who calls the func process? Amazing question. The engine. The engine will call it. Okay, Godot at the start of the game will keep calling it 60 times per second. So I know it's confusing, but don't worry. But I'm not gonna get any errors if I don't use it. Yes, amazing question. If you don't use Delta, you will not get any errors. Yes, but your game will not run like on the same speed across different hardware. So for example, on your PC, it will run good, but when you send it to your friend, he will tell you it's running very fast. The character is running very, very fast. So you're going to be confused because you forgot to multiply by delta. So because his PC is stronger than yours, it runs very fast. And maybe you'll send it to your other friend and he has a weak PC. He's going to tell you the game is, the character is walking very slowly. And you're going to be confused, you know? So exactly. Exactly. Yes, 10 must be multiplied by delta. Here, this code is wrong. Okay, the code here, for simplicity, so I can explain to you about input and stuff, I did not multiply by delta, but because now I'm explaining delta, yes, you should multiply this by delta. What defines the amount or speed or FPS delta is a variable that the system uses. Exactly, yes. Delta is, look, you do not calculate delta yourself. You just multiply. The engine will take care of it. That's why using game engines is so easy. Okay? Uh, Delta is just the time it took for the previous frame. Exactly, yes. Delta is the time it took for the previous frame to finish. Basically the frame rate. Exactly. عشان كده في جلitchات يستعملوها السبيد رانرز يغيروا عدد الفريمات. الله عليك. يس بالضبط. يس يصير جلitchات كده. فريم سكيب. Amazing. بالضبط. Is it like importing in Java? No, no. Importing is something completely different. ما له دخل بالimport. Okay, so here, you see the code we just wrote, right? Basically, when we finish writing the code, or actually at the start, we're gonna put it in a script. A script is basically a file, okay? It's a file on your computer, okay? So we're just gonna take the code and sort of throw it in here in the script, okay? And now we're gonna talk about how basically the scenes, here we have the player scene. Uh, the scenes themselves, unfortunately, they cannot do much on their own, okay? They're kind of like collections of data, right? Didn't I say that they're collections of these nodes, right? Well, the nodes themselves are collections of data, variables, functions, data. So if I just create the player scene, it cannot do much. It cannot move, okay? It cannot jump. It cannot die. It cannot do anything. Why? Because it does not have logic or rules or code. It needs not attributes. It has attributes. The nodes would be its attributes. It needs logic, okay? It needs algorithms. That's why usually when we create a scene, most of the time, we attach a script. So, for example, the name of the scene on my computer, I would save it as player.scene, right? And then I would create a script. I'd name it like player.script. And they have the same name. And then I'd attach them to each other, you know? So all the code you see here, I wrote the code for moving the player, right? Because I attached this code to this player, now this player will move. For example, if you remember the slime enemies, right? Remember them? If we give them the same script, we will control them. So the scripts are independent. You can attach them to any scene and they will kind of extend the scene, okay? They will give it logic. The logic that you yourself defined, the logic you wrote, the rules that you wrote. Okay, if nodes control what the scenes do look like, the hitboxes, the scripts are the exactly the kind of information. Well, I want to say information. They do contain information. You are going to create variables, but really, a script at its core is sort of is logic. Okay, you're going to write algorithms, instructions for the computer to execute. Here we have an instruction, a check. If input is action pressed, then move to the right. That's not data, that's logic. Okay, that's kind of a command you execute for me, you know? So a script is just a text file? Yeah, exactly. Yes, it's a text file. Basically, yes. It's not zeros and one. Okay? Some people think that. No, not yet. The compiler turns it into 0 and 1. Basically, nodes are the tools and the code activates and directs. Amazing, amazing. Yes. Exactly. I mean, very good. You summarized it. The nodes are kind of like the tools, and the scripts kind of control them. They activate them, direct them. Exactly. You know, they need something to control them. That's really amazing. Exactly. Okay. So here we can kind of summarize. We wrote the code, we put it in a script, and finally we attach it to the player scene. Okay. Yeah, like I said, most scenes kind of can't do much, so we usually give them like scripts for. So for example, the script that we attach to the enemy scene, the slime, is basically going to have not code for input, but code for sort of following the player, getting the position of the player and following it, and then dealing damage to the player. You know, so as you can see, it's different. Okay. Um, okay. Now I know that up to now we have got like so much information. I know some of y'all's brains are gonna explode, but hear me out. Just this one section, and we'll be done with the theoretical stuff. Then we're gonna download the program. Okay. So just bear with me. This last section, okay, is really easy. And then we're going to be done. Okay. So how do nodes and scenes communicate? Okay. So we talked about how like we kind of have these independent scenes. What if, for example, the slime enters the player scene, right? It's going to collide using the hitbox, but like some sort of signal needs to be emitted, right? So the player knows it's been hit. And that's literally it. Signals. Okay, so yeah, different scenes and nodes, they communicate with each other using signals. So as the name implies, basically when a specific action occurs, for example, a button is pressed, or for example, the player dies, or for example, a collision happens, the enemy hits the player, any sort of event, we can emit a signal. Okay? And anyone connected to this signal, anyone listening to this frequency, okay, anyone connected, they can react in some way. For example, when the mob, the enemy, when they hit the player, the hitbox emits a signal that the parent node can listen to, right? And the parent node will react. It will play a hurt animation, a hit animation. It will uh, it will take away the health. It will do -10 for the health. Exactly like a trigger. اوكي يعني بالعربي هذه الاشارات يعني حرفيا زي الاشارات اللي نعرفها ان لما يصير شيء معين مثلا واحد من الاعداء دخل على اللاعب ففي اشاره حتنطلق اوكي حنطلق اشاره حنبث اشاره واي احد مستمع لهذا الاشاره لهذا التردد بيسوي شيء معين يعني مثلا زي ما قلنا لو واحد من الاعداء ضرب اللاعب اوكي فالكوليجن شيب او الهيت بوكس حق اللاعب بيرسل اشاره لابوه اللي هو اللاعب تمام لان هي شجره عندها اب الاب بنقص الاتش بي تمام ومثلا بسوي انيميشن لهيت او هيرت تمام. An object entering an area, yes. Yes, signals will be triggered when an object enters an area. Boss area, yes. Damage, yes, exactly. Amazing. So here I have a simple example for you. So basically, I want you to imagine that we have this game. This game we have a player. This is a player, the red one, and we have an enemy, and we have a label, a score label, okay? It contains the score of the player. Now we have a problem. So we want, when the player kills the enemy, we want the score to sort of increase by 100. And of course, each of these is an independent scene. Okay, so like, how do we connect these two scenes, right? That makes no sense, right? That's confusing. The way we're going to do that is with signals. So before the game starts, when the game starts running, basically, there's going to be a signal defined in the enemy scene, okay? We're going to name it something like damage taken, for example, or no, died, okay? Dead. At the start of the game, the signal called dead will be connected to this node. Okay, this node will search for the signal and it will listen to it. Okay, so the signal will be emitted from here. It will go to anyone listening. This person will be listening. Okay, and basically every time this signal is emitted, it will call some sort of function. Okay, it will execute some sort of command. For example, here it's going to increment the score by 10. So here, let's see the simple animation. The enemy has died, okay? So it will emit the signal, and anyone listening will react. So because the score label is listening, it increased by 10. And that's it. That's the main idea. And Alhamdulillah, that's the end of our presentation. Now we will learn how to download the engine, okay? So before we learn how to download the engine, wait. Okay. Wait. Before we learn how to download the lecture, sorry, download the engine. Does anyone have any questions? So Sarah asked, like child and parent class? No, it's not. It's not inheritance. Okay. I think maybe you missed the start of the lecture, because we talked about how it's a tree, right? You guys have a Discord. No, we unfortunately do not. How did you get into game development, and have you worked on a real game that is publishing? Okay, amazing question. So personally, I've always I've wanted to create video games. Okay, I've had like a lot of ideas with like stories and like my own worlds that I just wanted to make like these big AAA games. So like right when I turned 18, right before I started college, I was like